Okay, so I'm just going to talk about a couple of design patterns, or what the concept of design patterns are. So in software engineering, a design pattern is a generally reusable solution to a commonly occurring problem. I guess, hold on. And then, or it's a description or a template for how to solve a problem. So it's kind of, it's not really a programming language concept. It's trying to take your programming language and retrofit it to what it is you're trying to design. So, for example, a Singleton pattern, which came up, may have come up in one of your other problems. I think it's the easiest one to follow, would be this. So basically the idea of a Singleton pattern is, suppose, for example, you're writing software to create objects, and for some reason you need to only create, you want to make sure your system can only have one of the objects. Right? Normally you create a class, and now once that class is created, you can make infinitely many objects if that class is typed. Right? Now suppose it's, let's say, well, this is a really restricted example, but let's say you only want to have one connection to a database, because the database only allows 600 connections, and then different sites each get one connection each. Let's just say hypothetically. We can change the Singleton to say, you know, only a maximum of 5 can be created, or only a maximum of 50, but it's easy to follow if we consider it a Singleton. So suppose we decided that we want to create a class, and then we add on top of that a special rule: only one object of this class should ever be created. Right? How can we do that? Once you put the class out there, anybody can come along and just start making stuff. Right? You have a class called clock radio that's out there, so anybody can just start declaring clock radios and start making them. How do you restrict them to only be able to create one of them? So does it make sense what we're trying to do? Right, we're basically, and again, the Singleton is the example where we only make one of them. We could say a max of 5. That it would just be extend this idea. But we're putting kind of a cap on how many of the objects we can make in our entire system. So if, let's say, for example, somebody already created one, and then you go to create one to use it, you're going to have to get the one that's already been created. You can't go and make a new one. Okay, so any idea how well, is there anybody have an idea of how to restrict an object from being created?
You could constructor private.
Yeah, so any object that you ever tried to create, the constructor always has to run. The constructor, we've always done this whole course, we've always made the constructor public. Right? It's always been in the public section. So anyone can call it. So if you make it private, then nobody could ever make any object. So that would be overdoing what we're trying to do here, because we'd like to at least create one. But yeah?
Couldn't you maybe even create like a count variable within the constructor so that you can, I don't know if this would work.
Well, yeah, I mean, these are kind of the idea, when I guess there was a famous set of 4 authors came up with a lot of these common design patterns. But let's say we took that idea, we had a static counter, so a static variable that said, you know, the count is 0. And then in the constructor, we could say something like, if count is greater than 1, then somehow don't construct anything. But the thing is, by the time, in that case, you would keep the constructor public.
Yeah.
At that point, normally when something's being constructed, the first thing we do is get the storage for it. And then once the storage has been gotten, we then run the constructor to kind of fill in the storage or take whatever initialization action was needed. By then it's already been constructed, so by then it's almost too late. But that's another useful thing, the counter, to handle other design patterns. So that's a good thing to know that's out there. So what we're trying to do here is we're trying to take features of the programming language to solve the problem at hand. So, like Pat says, we can make the constructor private. Okay, that's great, but now nobody could ever create anything. So, for example, what he's saying is, we could say in the private section, so let's say we have a class called Singleton. And this is just, it just means something that there's only one of. This could be database connection or whatever you want to do, whatever you want to limit the number of objects in our system as. But in this code here, we'll just say this is the Singleton. in the private section, if we put the constructor here, so here's a constructor that basically does nothing. But by putting this line here, it now makes it impossible for anybody to create one of these. If you ever said, in C++ or Java, if you ever said, singleton s equals new singleton, you're going to get an error, because you're calling the constructor, and you're not allowed to call the constructor, because it's private. So just by taking the constructor, even a constructor that does nothing, and putting it in the private section, you cannot make one of these things now. Okay, so we kind of overkill the solution. Now, we want one. We can't make any of them now. So is there a way to still make one? So what other things are available in the language? Well, the language allows us to make the concept of a static object. What's a static object? A static object means there's one for the entire class, not one for each object. So for example, like a field where we could keep a count of how many things we made, we would say static count. And that means there's one count field for every object in the class. They all share it, right? This just happens to be a language feature, right? So a static means there's one for the entire class. So we could make a static singleton object, and there would then be one for the entire class, and when the class got loaded, that one object would be there. So there'd be one object that will run as soon as the class gets loaded at load time. But we couldn't go and make other ones. Now what if a whole group of people wanted to share it? Well now, because we put the constructor in the private section, nobody could make one of these. But we could have a method called getInstance. There's actually a method reference. This reference should be over here. The method getInstance will return what I'm calling the one and only. And I am creating a static singleton object, meaning one for the entire class. I'm naming it one and only, because it's the only one there. I'm preventing the object from being created by anybody else. And now the thing is, I also want to take the copy constructor and put that in the private section, because I don't want anybody making a copy of the thing we have. And then also the equals operator. We never want to say one thing is equal to an existing singleton, then we can end up making a copy of it. So we put all of the functions that the compiler gave us for free. We put those in the private section. We actually create in the private section, so nobody can have access to it. Nobody outside of the class can have access to it. We create one object called the one and only. It's the one and only singleton. So for example, if this was a database connection, this would be the one and only database connection. Now you tell your developers, if you want to use the database connection object, the only way to use it is to call the getInstance method, which will return the one and only static copy to you, and then you could do whatever you want with it. And obviously, if other people are trying to use it too, they're going to be locked out. So can everyone think of a way, so does this first make sense? That there is a way to create exactly one. It happens to be that the language allows a static variable for a class. And we make a static of ourself. So it's a little, it's just a little getting used to, but what we're really trying to do here is we're taking an outside software requirement, a requirement saying you're only allowed to have one, let's say, database connection in your whole system. And maybe the database connection class is pretty complicated, so you write this really long class and then say, by the way, there should only be one of these maximum out of in our whole system. So then we start asking ourselves, what features does the language have where we can make that happen? Okay, we are allowed to put the constructor in the private section, so nobody could create any of these objects. Well, that's no good because we need at least one of these objects. But the language allows us to do statics. We're allowed to do a static, meaning we can make one of the objects, one for the entire class, and then we can put in the public sections ways to get at that one. So now you tell everybody, you can try to make one of these, but it's not going to happen. You're going to get a compiler error. But if you want to access it, you can access it.
Don't you have to say like singleton dot get instance?
Right, if you wanted to use this, you would have to say, you'd have to say it by class. There is no object, there's a class. So you would say singleton, in C++ it would be singleton : singleton : singleton. So basically saying for the class singleton, there is a static variable called singleton. And I want to call the get instance method of that. Right, so that would return to you access to the one and only object.
And then would you save it into, would you use an assignment operator?
No, then whatever it returned to you, you could then call with it whatever functions are also public. So actually there should be more public methods here, like if you wanted to, methods that help you use it. But that's the way you would get at it. You'd provide some method, you could make up some, get object or some kind of get method that would return the one and only object for it. Now you could, if you wanted to extend this to make it, let's say, a set of 5 or so, we could make an object that's a static. We could make an array of these things, like a fixed array of 5 of them. And then the get instant method would have to be a little bit more involved, figuring out which one's not in use and return the one to you that is in use. So we could expand this concept to a fixed number of a small number of them. So we could decide, like, if we, so for example, if you're using, MySQL has a maximum number of database connections to it, 600 or something like that, or whatever the number is. So if we had, we would never want our entire system to have more than 600 connections to the database. So we could create not a singleton, but a 600-tin, whatever that is, and then just say if anybody wants to connect to the database, you come to this get routine and it will assign one of the 600 connections that there are, and will guarantee we'll never go over that. So that way we'd never flood the database with connections. So this design pattern is just, in the case where you find you've created a class, and obviously when you create a class, it's free for anybody to come and make up as many objects as they want, but if you find yourself constricted to, I can only make a finite number, or something will go wrong with my system, we have to play around with other programming language to make sure that out of all the people out there, the maximum number they could create is some maximum that we set. So this is more called a design pattern. And the same thing's a little bit simpler in Java. So it's the same idea. We're creating a private, static, final singleton object called one and only. And we create we call new, calling singleton, so it'll create one for the class. And then, once again, we put the constructor in the private section. So Java has constructors that aren't destructors. But we would again put the constructor in the private section. So that way anybody on the outside couldn't create a singleton. And then we need a method to access it. So we have a public static singleton get instance, which will return the one and only. And C# version is slightly different. They have a read-only where Java used final, and I think that's about the only difference. Not the get method. So again, it's the same concept, just different programming languages. Okay, another fairly common family of design patterns is what's called a factory pattern. So a factory pattern is basically when you're manufacturing things, you're manufacturing objects of somewhat different types, and rather than have a constructor for each of the different types, and you have to know exactly which one to call, we could have them, based on the information you're giving to us, determine which way to create it. So an example here would be like a complex number, which has a real part and an imaginary part. And a complex number, I don't know if you remember from math class, you could do it with 2 integers, or you could do it with an angle and a radius. you can create a complex number. So there's two ways you can do it. Yeah, length and an angle, or an x and a y coordinate. And so there's two ways the data could be presented to us, and it could say, go create a complex number for us. And rather than have one method that handles it if you give two integers and one where a length and an angle comes in, we could have the code handle either case. So, for example, if they gave us the real and the imaginary numbers, we would create it, we'd have one constructor running one way, and if they gave us the angle and the length of the angle, the length away from the origin, we would create it a different way. But what we're really trying to do is create a complex number. So if we wrote one constructor, so wait, first of all, if we created a constructor for a complex number that took in two doubles, so all right, let me back this up. Suppose we wanted to have complex numbers be created two different ways, right? You give a real number, an imaginary number, or you give a modulus and an angle. Depending on which way you call it determines which constructor you run, right? We can have multiple constructors. And as long as the signature is different, when it gets called, we'll know which one to run, right? But suppose we have a scenario where the signatures are the same. See, it's called, the class is called complex, the constructor is called complex. Oh, wait, I'm sorry, down here. The constructor would be called complex, and it takes in two doubles. And we don't know which way we're calling it. We don't know, is this a real and an imaginary, or is this a modulus and an angle? Because they're both doubles, so we don't know which way it's being called. So how could we differentiate between the two different constructors? Is really what this question is coming to. So in other words, we're creating the objects with the same exact signature, but the creator would know which constructor to steer it into. Does that make sense? That makes sense? But so basically, it's kind of like if the constructors have different signatures, based on their signature, you would know which one to call. But if the way these objects are called is the same exact signature, but the creator would like to specify which way to create it. How could we do that? If we just did it with constructors, there'd be no way to differentiate that. So, suppose you wanted to have people have the ability to decide which way to create them by giving two doubles. So for example, they'd like to say, I'd like to create a complex number, C, and I'd like to call the complex but the polar coordinate version, not the real and imaginary version. So what we can do is we could make the constructor that takes in two doubles, make that private. Okay, and then the real and the imaginary parts are double. I'm sorry, yeah, the real and the imaginary parts are also private. Then we can make two public methods. One method that says, if you give me a real and an imaginary, I'll create it the complex, the normal complex way. That's whatever this method is. And then if you give me the polar version, I'm going to have to perform a computation first and then call the complex, the constructor. So really so basically what's happening here is the constructor, depending on how the caller wants to, depending on what the caller wants to give as input, will determine how the constructor should be used. So what we're doing is we're adding two other methods, from polar and from Cartesian coordinates, and then we make them call that one. So when you go to construct one of these, you can't call the normal constructor. You couldn't say complex and then throw in these two numbers, 1 and pi. You can't put those in. You have to say how you would like us to make it. And they call this the factory pattern because it's basically a factory is where things are made, and this is where you're forcing the people to give the instructions how the thing should be made. So technically, in the end, we are creating an object, a complex object, C, but instead of saying equals new complex and passing in parameters, we're saying this is how I would like you to construct it. And now I'm going to pass in parameters to you. And this goes to a public method, this goes to this public method, and then this public method does some computation and then goes and calls the now private construct. So really what we've done here is we've taken the way the object gets constructed and abstracted it, made it private, and then gave different ways in which you can call it. And then we just tell the people how to construct these objects. So there's no more calling the constructor. There's no more saying complex C equals new complex. That now can't be done. That would be a compiler error. Now we're giving them new ways of manufacturing their object, which eventually have to then go and call the constructor, of course. But we're taking their ability to call the constructor directly away and then giving them ways to manufacture their objects. So this is called the factory pattern. And is this code Java and C++ neutral? Is there anything in this code that you can tell which language it is? Public stack is in both languages. Sign is in both languages. Cosine is both languages. New is in both languages. I think this would work C++ or Java compilers, right?
That's how it would be assigned in Java on the bottom.
What's that?
That's the same that it would be assigned in Java with the equals like that.
Equals new means you're running the new method, which all the new method does is call the constructor. So this is just
Complex wasn't static in Java, would that be able to be called? Without newing it up?
if complex wasn't static.
If the object complex, excuse me, if the object complex wasn't a static, I mean, if from polar, what, oh, never mind, it is static, alright, yeah, never mind.
Okay.
Like I said, I shouldn't be speaking so.
Okay, so I think this code would run, I think this is bilingual code. I think it would compile in both compilers. I don't see anything specific to Java or C++ in it. Okay. Okay, and then the adapter pattern, just to cover up one more pattern. Okay, this ends up being kind of a wrapper class. This probably makes a little bit more sense in an example. But suppose, for example, we have a line. A line can be drawn from an x1, y1, x2, y2. So we have an x and a y coordinate. So basically we have 2 points. If you're given 2 points and you want to draw a line between the 2 points, that might be something you do if you're given 2 points. So this is really, this pattern, the adaptive pattern, is really on interfaces. So this is maybe a little bit more focused on a Java type language, but if you remember in C++, we can make an interface. All an interface is in C++ is an abstract class where every method equals 0. Right? That means if anybody inherits from, and then you would inherit it, you wouldn't implement it like you would in Java. You would inherit from it, and that then forces you to provide bodies for all the methods, and that ends up being just like an interface. So this is really an interface-based design pattern, and suppose we had a method called draw, and a method for drawing a line would be to take 2 points and draw a line between them. And then let's say for a rectangle, we had a method also called draw, which also takes in 2 points, same exact input, and then performs a kind of a computation, but draws a rectangular box between the 2 points. So we have the same method, same inputs, but they do 2 different things. Okay? So now suppose you had an array of objects, and in this case, we'll just have an array of 2 objects, but suppose we had, in this code, basically what we're doing is we're saying, if we had these 4 points, x1 is 10, 20 is the coordinates, and x2 is 30, 60. And then we decided we're running through all our shapes, and what we're basically doing is saying, draw these objects. Well, we don't know what types they are. For every type of object there is, we wouldn't know which class we were doing the drawing on. So what we could do is we could say, for the shape, we could call it get class method, so we know what type of class it is. And then we'd say, if the class is a line, then we would take the shapes object, casting it to a line, and call its draw method. And then it would know to draw the line between the 2 points. And then otherwise, if the class for the name that we got is equal to a rectangle, then we know to cast the shape to a rectangle and then call its method. And then that one has to perform some operation on the values so we can know how to draw the rectangle for it. So again, this is the adapter design pattern is really an interface-centric design pattern. That what we're basically doing is taking an interface method like draw that has an individual implementation based on the type of object, and then we're able to just go through all these objects and calling the draw one, and then it'll just adapt to whatever the type of the object is. So this is kind of like the object's types are established before our code hits, but our code would be able to handle any of that. Any of the type of objects, as long as it has the draw method and the input parameters are the same. Then we would know exactly what to do based on what the type of the object is.